Hey everyone, I am super excited to share something really cool. I have been working on my very own 8-bit computer. It is small, it is simple, but trust me, it is pretty awesome. I am going to walk you through how it works, step by step, and together we will even run an addition operation so you can see it in action. So let's jump right in and have some fun with this. First, let me give you a quick tour of the key components of this computer. Even look a little complicated, don't worry. I will pretty straightforward once you break down it. First, uh, databus and address bus. Think of the databus as the highway of data. It's move information between different parts of the computer. The address bus is like the GPS telling data where to go, especially which memory location to use. Next, 16 bytes RAM. This is computer's short-term memory, the RAM. It holds the number of instructions that we are working with right on. My computer has 16 bytes of RAM, which means it can handle simple amount of data at once. It may not sound like much, but it is enough to do some basic math. Next, we have 3-digit display and encoder. This is where we see the result of our calculation. The encoder behind it makes sure that the data from the computer gets converted into numbers that we can easily read. Next, we have important part program counter. The program counter is like the director of movie. It keeps track the current scene or in our case the instruction the computer need to run. It makes sure everything flow in right order. Next, we have instruction register. The instruction register takes that instruction and holds onto it while the computer figure out what to do with it. Next, we have address register. The address register is responsible for knowing exactly where in memory data or instruction are located. Then we have some cache memory. Cache memory is like a super fast notepad. We have cache A and cache B, two little pockets of memory that holds onto important data while the computer works on it. Arithmetic Logic Unit ALU. Now this is the exciting part, the ALU, Arithmetic Logic Unit. This is the part of the computer that actually perform calculations. Think of it's the math genius that adds, subtract, and more operations. Inside the ALU, we have got a full adder for calling numbers and a subtractor for subtracting them. Then, uh, then we have micro instruction counter. The micro instruction counter manages the small detailed step the computer flows. Last, we have control unit. Finally, uh, which is like the traffic police. It makes sure that signals go to the right place at the right times, telling the computers when to do their job. Now let's look at the specific instruction we are performing. I am using a software. The name of the software is Logisim Evaluation to input binary numbers in RAM or memory. Uh, Here, this software provides a simple method. Simply, we write down hex codes and the binary instruction puts in the register, which make it easier to present the instructions. We are going to perform an addition of two values stored in memory. Okay, so here we can see LDA 14, load 14. Let's say the instruction is load 14. It means we are loading the value at memory address 14 into the register A or accumulator. Okay, the instruction register IR instruction register receive the binary code of this operation. In this case, it is 00001110, which tells the computer to load from memory. Then many small steps happen. Then here the next instruction add 15. This tells the computer to add the value stored at memory location 15 to the value in the B register. Okay. Then A register and B register directly connected with ALU, and then ALU perform addition. Then the stores value display the result. Here out the instruction out, that means the result stored in output register which is directly connected with the 3-digit display. Then we have hold instruction, that means the state of the computer holds. We can see the output 42 here. We add two numbers and the result is here. Thank you for watching and I hope this give you a clear idea how. Feel free to have any question or comment below, and I would be happy to dive deeper into any parts of this process. Okay.